So thank you so much, everyone, for joining us for our joint AEE Pacific Northwest and the Building Commissioning Authority joint meeting. We're really excited. This is our very first hybrid meeting. So some folks in person and some folks virtually. So there's going to be some hiccups. So we thank you in advance for your patience as we're kind of working through the kinks here. But yeah, we're really excited to have this happening today. So really quickly from the AEE side, just wanted to announce our upcoming next meeting, which will be November 10th at McMinimans in Bothell. This will be in person only at the moment. We're still working on how to do that virtually at our annual meeting where we will plan the next year, as well as talk about open board positions. And we really do welcome both members and non-members to come to this meeting. It's typically a really nice time of fun and fellowship and getting to meet folks. So we're excited about that. We hope we get some great attendance. So I'll be turning over shortly to John Herboth, who's going to be running our presentation today. I will be monitoring the chat in Zoom. So if there's any questions or anyone's having technical problems, please don't hesitate to let me know. But also feel free to speak up. John's indicated that he really wants a very interactive presentation. So please feel free if you have questions to chime in or to join in the conversation that we're having in person. So quick bio for John. John is a senior commissioning engineer at Affiliated Engineers, Inc. He started his commissioning career in 2007 at Northwest Engineering Service and has 15 years experience collaborating with project teams and commissioning buildings. He is specialized in fire life safety and building envelope systems. He currently serves as the Northwest Chapter President of the Building Commissioning Association, BCXA, and believes that sharing project successes, failures, and best practices is a professional duty. So thank you and welcome, John.
Thank you. Yeah. Well, thanks for joining me. So this presentation is going to be on passive cooling and natural ventilation design, construction, commissioning, and sort of operation. It's the full gambit, to be honest. Previously, I did this presentation for the Building Commissioning Association back in 2019 with Ruan, a principal at PAE, Glenn Schneid from OTAC, previously Dacia PM. They've renamed themselves. And Matt Argyle from Climate Tech, who was the senior programmer on one of the projects that had 3 buildings. So I'm gonna try to do my best impersonation, Ruan, when it comes from the design aspect. I might have a mechanical engineering degree, but I am not a designer. If a lot of you know on the commissioning side, you really try to bring some of the aspects of your testing and in-field experience, as well as the operations side, and try to tie it back in and try to improve the design. You're not a peer reviewer, but you're really trying to bring lessons learned to the front and close that loop, and then collaborate with teams to try to fix stuff as you see it before it gets turned over. I think we all know what commissioning is, but implementation is everything, and how you communicate. So we're going to go over passive cooling and natural ventilation systems, and in the right climate zone, these can be very effective at reducing your energy footprint. But they've been mostly in office buildings, and I mean historically we've used passive cooling, on historical buildings just from a geometric design, the Tacoma Dome type setup, where you bring in using the building geometry to bring cooling through the building. Well, outside air, hopefully cooling. And so my experience mostly with educational environments, so K through 12 as well as higher ed. So this design concept isn't new. The application and integration with the controls and users is an ongoing process. So we'll be going over that. I hope that today that we can learn to identify some of the concepts and in the design and construction and operation of these components and assemblies. What are some areas of concern that we should be paying attention to, both in the design side, construction side, and operation side, some best practices, and then some of the responsibilities and implications for operations personnel, and solving some of the problems that do occur afterwards, because these are, it's like a living building. These systems will need to be adjusted. They will need to be maintained and accessed. And so that is really one of the things I'm going to hit on today, because that equals potential for a long-term success. So, you know, the driver for now natural ventilation design and passive cooling is energy reduction. And in our climates here in Seattle and Portland, we have ample opportunity to use this as a resource in design. And, you know, the concept is to decrease your conditioned airflow into a building, potentially disabling your conditioned airflow and bringing in the right temperatures, like your economizer function, except for directly into the room. And so you can really reduce fan power and mechanical cooling and heating potentially, because you can use it for passive heating as well in the right climates and conditions. So, you know, a lot of the designs, this is a picture of a newer building. I threw it in there because it's pretty. And they are really effective with in-space passive cooling and in-space heating, like radiant slab heating, because you combine the natural ventilation aspect to get all your outside air requirements met at the same time of being able to condition locally in the space. Don't worry about that. That sounds, was just something falling. So it really allows for each individual room to continue to control to its temperature without impacting the room next door. When you have an air handler that serves multiple rooms and you have space heating, you know, like our terminal unit above you right now, you know, if you're lucky, you have one per room. Not always the case. You might be grouped together with a few other perimeter rooms, hopefully not perimeter and interior rooms. And because one of the aspects that comes critical on the design for these systems is the envelope. If Ruan was here from PAE, he would, like, it becomes so critical to making sure that the thermal loading from the exterior isn't impacting the building, whether that's in the peak of summer or peak of winter, because then your radiant floor heating and cooling, along with an open air path into the interior, will make for challenges to your systems. So the better that you can have your envelope, the better performance you're going to have out of these systems. Now, we're going to get into the first project, and this is a higher educational site in outside the Portland metro area. I don't name names in these projects for specific reasons. But I was involved at this site to do recommissioning. Original design, this is a net zero building, one of the first higher education net zero buildings, what it was trying to achieve. We fell a little short, and therefore that's why we were brought in to do recommissioning along with the design engineer and a few other things. But in this design, we had floor level space dampers. So imagine below these windows that you have louvers and dampers down here, allowing air to come in down below. And then you had stacks with ducted and non-ducted above you, towers so that we get really good convection and almost a little bit of your stack effect going on. And on top, you have wind-driven turbines as well as powered turbines. So they're both, they function in two different operations, a neutral position to allow for wind to naturally move it, or for the motor to drive it. And I don't think it had the ability to lock and prevent it from moving if you didn't want it. We didn't get into the weeds on that one. This project, I want to say, is 2012, 2013 originally. I think 2012 it came online. So decade old now. And there's a lot to learn from it. We also had space lighting, you know, good daylighting coming in here, radiant floor heating, potential for radiant floor cooling before I showed up. So they had a heat pump chiller on site, all electric, no natural gas on site. The facilities team did not want no natural gas. They were not appreciative of that. But when you go for net zero, I mean, you don't want gas on your site. Now, for a facilities team that didn't want all electric, you know, that's because from their experience, you want the reliability of gas. bringing in a smart building, bringing in, a high-performing building is, I'm going to talk about a little bit later, has some inherent challenges with operations maintenance as well as staff and occupants. And it really takes another level to get it to start right and to continue to operate it in a way that's going to perform. Let's see. And then they had plenty of PV. One thing about net zero, you only have so much roof space. So part of the design aspects of why we look at reducing all the loads, everything from plug loads to your mechanical cooling, is because you have limited space. You have limited square foot for putting on your roof. You even have this nice overhang here to get sort of more potential space, but you can only get so much good PV on a site. It's not like you're going to take the field, I think they did on the field next door, and offset it by a massive amount of additional PV. You want to really look at your systems and subsystems and start reducing that energy load. All right, I think that's the basics there. So code line baseline back in 2000, probably 10 when this was designed, you have a pretty wide range of your load differentials and percentage. Now, the colors on this, I did not do the colors on this. Otherwise, I wouldn't have done light gray, slightly lighter gray, slightly darker gray. But, if your fan energy, I think was at 3.1% on the right on the model, and on your code baseline, I think it was 22%. So a huge difference in mechanical cooling. And that's because they are able to downsize the amount of cooling. This didn't have a dedicated outside air system, but it had heat recovery units, so heat wheels, and that would disable when your natural ventilation passive cooling was in operation. So as you can see, a massive reduction in fan energy. And when you do that, you can't downsize the mechanical equipment unless you're able to address your peak criteria for design day. So if that's why the envelope becomes so important, because you start taking down the requirements for heating and cooling on those peak days because your envelope. Here, the super insulated envelope was not employed, but that was a learning lesson from 10 years ago. So they gave us, I think they printed this data out and how close they were before I did recommissioning at the site. I mean, we're 15%, was it 20 out of 90? So maybe closer to 20%. They're getting there now. So when you start doing that on a net zero building, you're going to have, they didn't have metering, individual metering on all the circuits. You go, this is 10 years ago. How can you start tweaking and making sure stuff is set up correctly if you don't have individualized metering? So part of the project during recommissioning, we put additional electric meters on all the mechanical systems and individually by branch, so that we really could track down and take a look at why we were missing. Because if you don't have the data, you can't do the analysis side. Well, not as well. Start having a lot of asterisks. So here is the turbine ventilators and non-inducted shaft towers. And at the base, you had double sets of opposed blade dampers. So you really had, when you sat in the room, you could really feel the air going. We would have returns in the ceiling. So a return plenum in the ceiling going to that. Or if you were in the hallways, then you would have large grills at several locations to bring air through the whole building. So, I mean, it felt like somebody had a ceiling fan on. They did have ceiling fans as well. So there was a lot of circulation and trying to bring occupant comfort into the building. Obviously, you don't want it high enough to ruffle everybody's papers, but even in 2012, we still have, computers on site. Now, one aspect of the design on this building was there was a lot of user controls. Now, I don't know how many, has anybody been on a project with passive cooling or natural ventilation? Anybody? Okay, I can make stuff up then. You? So just a little bit. Any experience in the field at a building with one?
Well, I know a lot of the build out in Sept, South Lake Union for Amazon had mixed mode ventilation. So passive cooling was the first stage of cooling.
Yep.
So red light, green light
Yep.
system ended up being disabled because there was so much noise from the surrounding traffic and streets that people wouldn't open their windows to take advantage of that.
Yeah.
They would leave them open, which is a filtration security issue, and it never really materialized as a strategy in the end.
Yeah, that is, we'll go over it some more. Some of the aspects. So we're going to go from this first project where we have double damper sets to try to reduce that air infiltration unintended, as well as sound dampening, to the next project where you have operated windows, which have had a lot more success on the ceiling side. I'll get into that.
One question I do have on that, did you do any of the energy modeling of the proposal?
I did not.
Because I'm just trying to figure, maybe Kristen knows how to model passive cooling. Is it an economizer without a fan?
It's very tricky and it is software dependent. I don't know if the folks online can catch the conversation we're having. So
But anyway, I don't want to get into the weeds, but just curious.
it's not straightforward.
Right, because there's mass, thermal flywheel effect, there's a whole bunch of.
Yeah, it's not easy.
Yeah.
It's not easy. And you really, I have some graphs here. We'll start taking a look at your hours of operation that it can, and reducing your mechanical cooling and heating. So at this project, we had everything from louvers for lighting to fan speed for your ceiling fans, a fan enable for the turbine ventilator. So an override on and off control, damper override. So that if there was air coming in or sounds outside, that they could close it, or they could manually turn it open 0 to 100%. So, and then, you know, your CO2 sensor and lights. So a lot of user controls, and that can have some inherent challenges, especially with staff and occupants, making sure that stuff is clearly labeled. And even if it is clearly labeled, and explain to staff that you have everything from turnover to not a good understanding of the system. And I think that is always a challenge for engineers and architects as well. Anybody, is to communicate how things operate both functionally and conceptually at the same time. Because if you don't get it conceptually, it's really hard to understand it operationally. That's the life story for us anyways. So here is the double damper set. So 2 dampers stacked deep, so that we can have, and I think they were closed. So I think they closed parallel wise, and they were in opposite directions. So not opposed blade dampers, parallel dampers with them inversed. And then they were encased in a box basically with, you know, big grill in the front and then casework on top. So access was an issue to this, but as you can see here too, there's only 1 actuator per double set. So for quadruple, so 2 deep is how they're done, and then 2 wide. And so you have 1 actuator and you have linkages. Does anybody smell a problem with that? So we'll move on. This is what we get when you have double damper sets. That first damper set, the bottom right picture, you can see the first double set is warm. It's doing fine. But the second double set farther away from the actuator is cold. And you have 53-degree air coming in. I don't know about you, 53 degrees on my neck, on my legs, not very comfortable. Go ahead.
We have an online comment. How do you keep teachers from putting stuff on the sills, or does it matter?
On top of the sills wasn't an issue.
Wasn't an issue.
Was not an issue. Debris tends to be the biggest issue when you have floor stuff, but this was air coming in for the most part because of our turbine ventilators. But we did have enough debris building up from, you know, your screens on the outside. So you're still going to have an architectural screen on the debris on the outside, I think now you would also employ a sort of a rain screen as well, to try not to bring water too far in. So fall and winter conditions really worsened everything, as well as during the summer, even though it was less used, and that would be dusts and everything, because there's no filters. So you have the potential there, if somebody's mowing the lawn or creating dust outside, you hit the override and you close it. But it shouldn't be open too much in the summer anyways, unless your temperatures, are 70 to 75 degrees. Ceiling fans and the ventilation was not enough on hot days with the classroom spaces exceeding 80 degrees. They literally, on the southwest side, they could not use the spaces by, I think, mid to late, about late May, once your temperatures really got going. Even though it was, say, only 80 degrees or even 78 to 82 degrees, your thermal loading on a sunny day was really starting to impact the spaces. Go ahead.
Along with the building earlier in the day, earlier in the morning.
So the question was about flushing, night flushing. That was not programmed in. And so part of our recommissioning, I'll get to it in a second, we did start to implement a control strategy for that, as well as this slab had never been used for cooling. No one had the cojones to try it out, which is a little bit odd when you have a system that's being commissioned, as well as an engineer trying to really get net zero and keep it comfortable. That I don't know what happened. I wasn't there on the original, and no one seemed to explain why cooling wasn't tried out. After I went through the commissioning report, it seemed like there was a sampling strategy of the mechanical equipment. And so I think there was a real hours reduction on the quality of your QA/QC, and really vetting that out. And we all know when you leave the site after we get demobilized, getting stuff fixed after that point is diminishing returns, even in that 1-year warranty period time. Let's see. Yeah, no one likes drafts. All right, so revisions. So they took a lot of work to pull all that casework out, go to a much higher class of and lower leakage of dampers. And we basically got the best commercial damper from, I think Ruskin. Yeah, Ruskin. And as with a really good gasket on there, we also upped the torque on our damper actuators and made sure to set those correctly to just prime it, and just turn it a little bit more past it. You have to be really careful when setting damper actuators for their 0 point, because even if you're like, oh, let's just over torque it, well, then you're going to fail your motor real fast, or you're going to potentially damage something. But most likely, depending on how powerful that motor is, you're going to lose that motor in 10,000 cycles instead of 20 or 5 or 2. I mean, actuators, I'll get to that in maybe a different presentation. Actuators, they fail a lot. So they also insulated in there. So before, when they opened it up, the casework, there was no insulation on top, and that cavity around the actuator wasn't really insulated, and no sealant for all the corners. And so you were getting drafts around the assemblies as well. And so you go, oh, why? Why was somebody not paying attention? This is why building envelope commissioning and consultation has really taken off so much, is because there's such a large need. Go ahead.
You know what project delivery model is used?
I do not actually off the top of my head know what project delivery model it was. It was a higher education school. So usually, back in 2012, where we're doing still CMG, probably. I'll look that up. And can you log that, Kristen? See if I can answer that in a follow-up email. And we'll see. Anybody else had a question? Did I see a hand? All right, I'll keep going. So going to single depth, just a higher quality, not double set, even though the double set wasn't a bad idea, but having them using one actuator and linkages, not so great. So I would actually be still fine with double sets of damper assemblies, but their own individual actuator would be helpful. High quality components, sealing, you're going to get rid of 95% of your issues there. And accessibility, you need to be able to see or be able to monitor somehow that you're not having leakage in there. I'll bring that up in a different example, but if you say had an inlet temperature sensor for a couple of these, you could actually then say, oh, I'm seeing 55-degree inside the space. You'd obviously want to mount it sort of a few inches away and make sure that it's well insulated, maybe an insulated damper set so that you can see what a baseline is and have some sort of alarming capabilities. Anyways, and then part of our revisions, we also really staged how slowly they opened it up and making sure that we did not open up from a command of 0 to 10% and avoiding a 1-2% open in the control PID loop and stuff like that, and to not recognize that even if they move the dial like 1 or 2%, we're like, until you say 10% open, we're not opening it up. Go ahead.
Did the occupants make any comment about the noise of the actuators at all?
No, actually, I don't think we received a single comment. We had an extensive smart sheet log from staff, and I had direct tie-in with the staff over, I'd say, about a 6-month period of time, and that never came up. So the question was about whether or not we had any noise problems from the actuators. You put a fan though in a cabinet fan, then you might probably have that type of stuff.
Real quick, so the user input, were they two-position, open, closed, or were they
fully modulating 0 to 100? And
with
so
just a dial
with a dial, yeah. I don't know if on the dial it actually said 0, 50, and 100 on it. So it might have said open and close O and C or something like that. So another aspect of this is that on our turbine ventilators, we had a nice nest going on in one of ours. And so this was the modification by the facilities staff to try to address that. The only problem with turbine ventilators on top, you can get those out of balance very easily. And so that actually started generating its own noise problem as well as the bird that was originally in there. So that's how the staff knew, because they heard, you know, the circle of life happening inside their classroom or above their classroom. Another problem here was accessibility. I don't think this picture does a very good job of it, but getting to those upper ones, this lower one was easy to get to on a flat roof. The upper one, there were very narrow metal roof. Getting up to that point, there was no like stair path, there was no like flat ladder or anything going up that way. So accessibility to get to those turbine ventilators was a huge problem. I don't know if I had the picture yet. Let's see. Okay, here on this picture, you can see how they are way up there. I mean, we're talking 50 feet, you know, up, and even 20, 30 feet above the roof, the flat roof line. And so, and you can't get it from internally. There is a mechanical space above the atrium walkway. And so you need a lift just to get to the mechanical equipment, and you'd have to open up the fun, you know, 12 screws that don't really, you know, screw in very well. You know, the doors up to these mechanical rooms weren't very high quality either. And then there was no D-ring, so you'd have to step off the lift through the rails or open up the door by, you know, having it situated correctly and then repositioned. And then you'd have to have an extension ladder up inside a 20 to 30 foot, you know, shaft. Yeah. Accessibility was not designed into this. It sure did look great, but it was not fun. I personally love climbing. So I usually tell people when I go through stuff, if I can't get to it, I'm tall and skinny. I'm probably down to 6'1.5" now. Starting to shrink at 37. You know, no one's getting to it. No one's getting to it. I can't get to it, and I like getting to stuff. Trust me. Yeah. So we talked to the facility staff about, we went and recreated their instructions in the classroom. The architect actually had a really good user manual, but it was like 9-10 pages. for the one for like usually 1 to 2 pages per type of classroom, whether it was the administration area, the atrium lobby, or the classroom. But we really started simplifying it down to if you feel cold, if you feel hot, type of deal, or unwanted, this is what you do. So a real untrained reaction in when you're what to do. And then I personally held training for the maintenance staff. I found this extremely valuable. I don't know if it was effective for this particular project, but having somebody like a commissioning agent or even the engineer or the architect or all three, having them lead training and interacting with your contractors doing training is way more valuable on a high performing building. Because I know from my commissioning is like, I'll review training agendas and materials and stuff like that. I'm like, it's like 4 to 6 bullet points if you're lucky, of what they're going over. I'm like, okay, are we starting in the classroom? I want an agenda. I want a conference style, training, for a high performing building, because there's just so much going on. And a lot of the trainers that I talk to, unless it's their full-time job for training, and even then, they don't modulate based on the users and the type of building. They don't modulate, the audience that they're doing to. And then if it's a recording, whether or not you're actually getting good questions or not good questions. I was used to really going through and doing my own questions and really beefing up the silent in the room during training. But it's becomes so important for training to be very specific to your audience, whether or not the staff is strong or not, and then having that recording actually be valuable by having somebody in the room ask those questions that somebody's not asking. I'll get into that maybe on a later date if you guys want. The accessibility was just horrendous, and they didn't assign a maintenance staff to that site. When I went through, I think the filters hadn't been changed in 2.5 years. So, and that, again, accessibility, it's like having a red blinking light at a site, when you first turn it over. The ownership by the O&M's team, you put it in peril by giving them problems to start with. Let's see, this is one of the heat recovery units, 2 of them in one of the mechanical rooms, pretty easy to get to. So that was great. We ended up doing full device checkouts for the commissioning and a condition assessment of components that weren't working, adding that metering and trend review so that we could start isolating the net and reviewing the reason why we weren't making net zero. And the controls changes, we also went through and tested slab cooling. I got to hit that button and swap it over. It took about 2.5 days to go from heating to cooling. Knowing that, then we took a look at adding weather forecasting. We were lucky enough that web-based data was available that could get inputted into the system. So they could start grabbing it. And by, I think this was 2015. 15 is when I was there. And you could start grabbing that data. So you could start pulling the next 5-day, 7-day forecast. And we put in programming that if we saw 85-degree, I think we landed on 2 85-degree days in a row, both adjustable, how many days in a row and what temperature, that it would automatically do slab cooling, and it would start doing flush, pre-cooling of the whole building. So we did pre-flush the night before, depending on a low temperature threshold. Usually I think we started that if it was below 60 degrees at night, or it might have been like 62 or 64 or something like that. Start pre-cooling the building down, knowing that there was going to be a hot day. I think the limit on that was like if it was planning to be a 78 or 80-degree day, that we'd start pre-cooling the building down, especially if we weren't doing slab cooling. And then we would really try to, when slab cooling was going to be in play, that we turned on that pre-cool for the entire evening. Because there's a big difference in lag time. Say you're using the space temperature. And all of a sudden you bring it down to your 65-degree pre-cool. Well, it's going to rebound. You know, you have thermal mass going on, and you're not going to pre-cool the whole building down to 65 degrees on the slab temperature, which is inside the slab, because then you're going to have to, you'll drive down the space down to 50 degrees and with no lower limit. So you're not going to get that during summer, most likely. But so we really started making adjustable implementation for pre-cooling and weather-based forecasting for slab cooling. And I should probably check in on this project to see how that's going.
Yeah. Just got a quick follow-up.
Yeah, go ahead.
So now I didn't know you were doing slab cooling, so that makes, could you have done like you said, like kind of like in phases, like try slab cooling at a certain temperature, and then it's like one above 85 forecast or whatever.
That's
you would bring in the pre-cooling methodology, and then you would tie in both together.
correct. That's what
Save energy in some way.
that's what we did. We used the night flush. No, we would if there was a plan to swap from slab heating to slab cooling. So you had those 85 to 90 degree 2 days in a row at least in the forecast. Then I mean you have to do this at least 2 days in advance. So what we started to do was switch to slab cooling, bring it down to a neutral level, and then to slab cooling the day, like the morning of, using the night flush as well, if it was available. So like it was one of the more complicated aspects that I have ever been in. And I don't think I've done one that complicated still. I was the worst nightmare for that controls contractor.
What approach did you use on the dew point avoidance? How many degrees?
So we stuck to 2 degrees, but we used, we had slab temps in every single room. And we made sure that we did not, we used the lowest 2 values as our values there to avoid. So we really tried to give ourselves a big buffer. People wanted 5 degrees, but that was a pretty far off temps to get not having a good enough cooling from your slab. It was adjustable. 2 degrees was what we settled with, as I think we started with 3. And then I think after we watched it and got confidence, that we went down to 2 with our reliability of the sensors. And we did check sensor accuracy throughout the entire building.
How long do you find that sensor accuracy lasts?
So that is a complicated answer.
Yeah.
Maybe not diplomatic might be the right word. So when we went through, we're using our calibrated equipment, it's got its own inaccuracies to it. So we compounded the accuracy of potentially of both to take a look at if something was, for me, it's usually if it's within 2 degrees, I'm fine. And once you get to 3, then you're like, let's start adjusting this. 4 degrees, definitely adjusting it. I don't think I've adjusted sensors more than a sample check every year. So, and that's a sample check. So that was part of our O&M process, was to do a sample check, as well as, using a FLIR, to go around. Obviously, those work really great with reflective materials, but that being one of the O&M checks that they do. And you can see at a smart building, your O&M checks start going up. So funding for O&M needs to go up. Don't think we need to fight on that one. And then I think that was it on this project. So biggest lesson learned, I'll hit on the same points that I talked about earlier. The draft potential is one of your worst aspects to natural ventilation on the design considerations, and one that you should be paying attention to the most, as well as tie-in of those water and air barriers to that assembly, and making sure it's insulated around, yet still fully accessible and able to remove it, because that is one key component to this. Damper assemblies also potentially will start to get a little drift in their fully closed position potentially. So integrating insect screens below the turbine ventilators is a great idea, as long as they're not too deep down. That creates a spot for a nest. So you really want it right below that, the moving components in there, so it doesn't give a chance for a roost to happen. But you definitely don't want it on the face unless that's integrated from the manufacturer. Accessibility, high quality components, and QA, QC on the installs, making sure that we are tight everywhere, as well as accessible and removable. And then training, reliance on those installing contractors to do all the training is setting yourself up for high risk of not getting a quality training program started. All right, so this next project, let's see if that will hide this up here. I don't know why this bar is not hiding. Okay, well, anyways. So this next project, these were 3 sort of prototype buildings, so they're very similar. This was for a K through 12 school district in the Portland metro area. And we started out, Ruan and the PAE team really went through and started taking a look at discussions with the owner and going over what they wanted. And they were really trying to go for the best energy performance that they could get. Net zero ready was what the district wanted to do. And they were trying to look for ways to be cost effective at the same time. Districts have limited resources. Luckily, this was before all of our pricing increases everywhere, destroyed budgets. So they really went over after the best energy performance that they could do and really get down on, let's see, this really is bothering my screen. I hide this. I'll just keep going. So what they did was, this is our climate bin for Portland metro area. Your hours per year that you would be able to do passive cooling in. And you see about 3,000 hours, just a little bit over. And this was with your sort of code baseline envelope. And there's your active heating hours and your active cooling hours. So this was more like your economizer hours in Portland, if you were to graph it that way. This is your bin if you have a super insulated envelope. Massive, massive difference. Almost to the point on design where you go, do I need mechanical cooling? Now, obviously, trying to convince somebody to not mechanically cool a building is not going to fly. Specifically for this district that had a contract with their teachers union where room temperatures had to stay between 68 and 74 degrees. Now, this says, you know, you're down to under 300 hours where you would get above 80 degrees, where it would be to unusability point. So that those next 2 bins over, 70 to 75 and 75 to 80, you know, those probably doubled and tripled that hour count. So that'd be 900 hours if you wanted to keep it. So 600 hours if you want to keep it below 75. So that's just not possible. And for me too, you know, you don't want, unless you have a very specific use for a building, having a building that could be unusable, especially with climate change as happening right now. Our hot days are getting hotter and more frequent. And, you know, not having mechanical cooling, just like having not enough heating, say like a VRF system where you have to run it 24/7 to keep at 72. If you're east of the mountain range, you better have some way to reheat a building up after, say, a power failure, or you'll never get the building back online in a few days. But anyways, they went through this and they talked with the district and they said, we love it, we love it, we love it. But we have to have mechanical cooling, at least in the classrooms, you know, for where all of our teachers are. And in all honesty, you know, you can't even use passive cooling effectively in gyms and kitchens and other admin spaces and stuff like that very well, just because their use, the way they use the room, and potentially also with your heights as well. It doesn't come from a practical kind of standpoint. It's not as easy to control in a classroom environment. It's just so much easier. So the energy use breakdown is right here. And so let's see if I think I have the next one. And that's our ventilation fans are about 18%, spacing 30. We had a pretty good broad base with heating being your most of your energy use, and then ventilation 18%, and plug and lights. Here's your heating energy. Infiltration, is at 18%. Your window heating energy is a big part of every exterior classroom or any exterior room. Your wall heating energy wasn't that a lot, and ventilation, I bet you Ruhan had some better things to say about these than I do. But here is your passive approach system. So we now have operable windows instead, with a green LED light to say that it's a good time to open up the windows, and then a heat pump thermostat to keep us regulated. For this project specifically, they did not. Originally, we're talking about disabling the HVAC unit when the green light was open, but they didn't have open close statuses. They're manually operated, no status of whether it was open and closed. If you wanted to turn off the heat pump, I would recommend having a contact closure, sort of like one of your security devices on those operable windows to be able to do that and turn off the stuff. But we had a DOAS system. So, and this was passive cooling, not natural ventilation. So the DOAS was specifically meant to operate all the time during occupancy, and our windows operated only as passive cooling to provide additional cooling to the room and reduce the cooling by the VRF system. And so they did stagger for stage cooling, when that green light was lit. And then second stage would be that heat pump. So they had an offset of temperature set points and stuff like that so that it could be effective. So that light would say come on at say 72 or 73 degrees, and then mechanical cooling would turn on until to keep it at 74 and keep it within that range with the district's contract. And here we have the same type of setup. We have a shaft and going up to a doghouse, turbine ventilators on top, motorized dampers up top as well. The previous project had a 2-position. This had a fully modulating damper set, high quality. Again, we learned from our previous example and went for high quality there and low leakage, as well as tie-in. So this is what the ventilators look on top. I think they ended up doing a nice matte finish rather than super reflective. We had during construction a fire generate from storage of said parabolic mirrors horizontally on staging, which took out one doghouse. I do have pictures, but I did not put them in this presentation. Okay, I'll keep them. And so you can really see that on our heat load, we had a bounce point on the BTUs here. I'll just keep moving through this one. I don't have a good explanation, but here were all your functions here for passive cooling, from everything from your baseline loads to natural ventilation to your night flush, all the way down here on how much that would increase your ability to stay within that temperature window and under 74 degrees, 74 and under. So there's a lot of different functions that were evaluated and pretty aggressively with the energy modeling and how it could address the energy for the building. Here is that map I was telling you earlier, how we only had passive heating and cooling in the classrooms, standard conventional heating and cooling in your gym, cafeteria, and sort of administrative areas. And so it really, they tried to make sure to use passive heating and cooling where it'd be the most effective and the most usable. And rather relying, say, like on a teacher to control the cafeteria where they're never at, or something, or an administrative person to control something that they're never in. And then this is what they had in the field, much simpler. Your standard thermostat, smart thermostat, just an LED light saying green when it's good, and if not, it was off. and then your ceiling heat pump. So this is one aspect of this project that is critical on the design, especially as you're developing it and hopefully not trying to turn it around too quickly, is the integration of the air, water, roofing membranes, which people like to use for air and water, even though that's not a great idea to use it for air. The detailing level, we had RWDI come in and really help the team get those details spot down, and then put it in front of the construction team on how to construct it. Because it's one thing to have it detailed, it's another thing to be able to construct it. Two-dimension walls, great, easy detail, constructability. I know how to layer stuff like that. You start getting the ceiling to wall transitions, floor to wall transitions. Soffits are a huge problem, those truss connection areas. Same thing for this doghouse. Making sure that we had ability for water to get out of there if it got in, and making sure that the shaft was sealed and treated like this doghouse was outside of the envelope, and that our here along that damper louvers would be considered your air and water barrier into the building. So that was insulated. They were insulated as well. So building envelope consultants, worth it. And the problem though we still ran into was, okay, we probably should have painted the inside of that shaft, instead of just using den glass. Now you have an accessibility, that shaft, integrating a D-ring in there or something to be able to get in and fix something if something got in there. Say a bird somehow did get in there, that to be able to access it and repair something or inspect. So accessibility is still in these shafts should be a consideration, whether it's a D-ring, a place to tie off to, as well as removable damper assembly so they can't pass it or from down below, and leave a rope in there or something. Some way to access and inspect is a good idea. But yeah, and there is some of our roof. I think this is where I was going to put that picture of that burnt down doghouse, and I decided not to. But those revisions really did help. Everything from drainage to accessibility, that screen location, having a matte finish on those reflective turbines, and externally mounted actuators that could be swapped out when they fail. So that's what they looked like. So they were talking about painting the inside of that dense glass and having a more wipeable surface potentially, or keep it a little bit cleaner, or protect it. Yeah, and there wasn't really much user controls. A user enable and disable switch, auto resets. They really simplified the process to just say, hey, it's a good time to open up Windows and enable the system. And then retraining, we really did focus on training the staff in person with the commissioning team, which was Northwest Engineering, and making sure that there was a yearly checklist for the O&M staff to go through, and getting the support of the district to make sure that the staff had enough time to do that type of stuff, and making sure they understood there's always all this money up front, capital projects, to build these good buildings, these new educational facilities. When you get new square footage or renovated square footage, rarely does your O&M budget go up. So that is part of something that you want to set them up for success, and use as much capital budget to set them up as possible going forward. And I've even had payments to the commissioning team to step in and help monitor and operate this and check for issues throughout that 1-year warranty period, rather than waiting for an email or phone call. And I think post-occupancy challenges, I think the lessons learned primarily from this was getting buy-in, both on the concept to the whole design team and the construction team, getting them to really go through some of those details on the constructability, because this is not something construction teams are used to building. Just like for this room here, for your experience with natural ventilation and passive cooling, getting those details really dialed in and reviewed, and then talk about some lessons learned from past projects, and then accessibility, being able to remove components and replace them becomes a really important part. How am I going to get this damper assembly out? Is it just face mounted? If it's in a wall cavity like this, do I have to remove a rain screen first or a screen first and then get to it? And then the way it's fastened into the building, I need to be able to access those fasteners and pull it out. I think that is about it. I actually got this from a coworker of mine. So I threw it in here. So this is a new design here that I'm reviewing right now. And as you can see in the top right, there's that rain screen louver. And then there's a heating coil actually after the damper assembly. And so me and the team are going to talk a little bit about how this is going to be, the details are going to be really gone over with the construction team and design team, and probably elaborate more on the requirements for this, because this now would be a great spot for a supplier temperature there right on the inside of the wall to the left. You could have one right after the heating coil there. You'd say, if an alarm, you could say, if the valve is at 0% open and outside air temperature is, whatever, below 60 degrees, and I have that supplier temperature saying 6 degrees or less, we need to go look at the damper assembly. So you could start implementing some potential to start picking up if something is not working correctly, just like a valve leaking and you have heat generating when it's supposed to be closed. So I think that's it. Questions? This is my favorite picture that I like to throw on these.
This project is high volume, mostly no.
I don't. The one that I just had up there.
Did the first project or
The first did. The second project, I actually can't remember if the classrooms. Do I have a picture diagram of the classrooms? I think I did.
I would probably keep maybe not. I don't know if that distracts.
I think it was the type that had, since you had ceiling heat pumps, I don't see any ceiling fans of that one. Yeah, no ceiling fans on that second project. All right, other questions?
Online, any questions?
Go ahead.
No, you're way back when you're probably on your initial slide of the building, you had phase change.
I did.
Any comments on that?
So I haven't been on a project with phase change material. Think of it this way. It's just like these on top of this building here, you have hot water and cold water storage tanks, implementing a way to retain heat or reject heat becomes a way to improve the comfort in your building and utilize that thermal loading into your advantage. So that ends up being an energy reduction strategy, but I have not been a part of a project and have any lessons learned to bring to this table here.
Those basically stuff I didn't expect very often.
I wouldn't assume not.
Like one of those things I've heard about for a long time. Basically, fast company or something.
Yeah, it's probably with one of those learning labs type buildings is where it would be a good place to implement something like that, because it, just like any smart building, you really need to be able to monitor and adjust, and that's what we tried to implement in that first project for that higher education site, was adjustable points, adjusting the sequences to start taking lessons learned of what's a problem area and trying to stage it or mitigate it in some way with like night flush. That takes effort to tune a night flush to work correctly. I remember when I was first going through it, I'm like, good, got the space temperature down. It turns off. I'm like, no, why are you turning off already? 15-minute delay, 30-minute delay, or, you start having to put some sort of delay or a low limit temperature. And then it's going to cycle throughout the night and do night flush because it rebounds from the thermal load. You can't calculate with your control program the thermal load. Well, at least I don't have that calculation. What your active thermal load is on building. So Anyways, anything else? Go ahead.
Online question, there's two actually. Can you satisfy ASHRAE 55 with non-operable windows, but utilizing floor-level space dampers and exhaust stacks?
I am not familiar enough with that. Anybody know ASHRAE 55?
55 is the filtration standard, or is it, or is that 52? 55 is thermal comfort. So what can you maintain that personal dissatisfaction index at less than 10% with passive cooling? I doubt it.
Well, from that load profile previously, there's going to be 300 hours a year. It comes down to your peak design day. You know, if passive cooling can be there for a good portion with a super insulated envelope, but if you don't have some sort of chilled beams or some sort of mechanical way to cool it for those peak days, you're likely going to be in trouble even with night pre-cooling, because not every night you're going to drop down during the summer. On those 3 days of hot in a row, that night you won't get below 70. You won't get below, maybe if you're 75, you know, once the thermal mass of the ground starts going up, you know, it's really hard. And that's why it's really challenging to become effective with energy reduction and still address these changing peak design days and quantity of peak design days.
Another question, what was the metered energy usage after the commissioning on the first project compared to before?
I called up Interface. I bet you, I want to say we got there. And so I want to say it was at least a 10% reduction in energy, and we were either 5% under net zero or like 1 or 2% over. It's been a while. I'd have to, and I lost my email history when I changed work, whether I could go prove that. But I can make a call if you want to log that down. I will gladly answer that in the email and provide some details. Be a good phone call to have with a friend of mine.
I'm sure you have some stories about working with design engineers as a commissioning engineer yourself, and whether some folks are receptive versus less receptive. You know,
and my personal opinion has also changed in the way I interact with other engineers. I mean, I have a mechanical engineer, but I'm not a designer. I have completely, when I first started commissioning, they're like, you know, the ideal commissioner, you know, I didn't believe it, to be honest. I didn't believe that I could be, I had enough experience to be that person that could be collaborative, could bring value to the table, because I didn't have enough experience to do it. Now, when you have enough horror stories, good stories to go along stuff, you can actually, and you have the relationships too with those companies. It's so much easier now to pick up a phone or do a Teams meeting or something with Signer and go through those comments. One critical aspect of commissioning is and will always be communication. And if you can't establish some sort of rapport, even if you're a competing firm with another project team member, then commissioning is not going to be effective.
So I'll come in as a recovering design engineer. The reason why they didn't do the cool slab is engineers are risk averse. And the potential for condensation and a variety of things.
The risk.
Yeah.
Risk. I mean, commissioning is risk avoidance.
So we tend to over design and very conservative. And then the tuning, like the commissioning agent or the owner does in that post occupancy period, is super important, because they can then squeeze out the energy cycle, implementing the chill floor.
Yeah, starting with a 5-degree difference between your dew point, and then start whittling it down. But you're the one that overrided it, went it down. You know, these are the conditions I designed it for, type deal. I mean, that process is always fun to tiptoe around sometimes.
Yeah. And that changeover is kind of unique, because I know at the Hoover Union building in Pullman, they did passive cooling, radiant cooling above, and they would get temperature swings happening very quickly, like a thunderstorm moving through Pullman, and the humidity would go boing, and then it would be raining in the tub building because they could not respond quick enough.
Correct.
To water temperature.
Correct.
So
and that's what we started with the strategy. Luckily, we started the recommissioning on that during the summer, as we were redoing all those damper assemblies. And so I really got to see got to first test the chilled without any occupants really in the building besides some staff members who were my guinea pigs. They were lovely, by the way, out there. And I won't name the building. And so you really got to put the hours in. And the only reason you got to put the hours in is because I had the hours, and from a design standpoint, you don't have the hours to go in and do all this tuning unless somehow you convince somebody the value of that for the operation of the building.
Yeah.
And so, tricky to get the hours you need to do that type of troubleshooting. And I've actually been an owner rep before for a little while. And that was actually a fun experience because I had an unlimited bucket to go do the work that nobody had the scope to do or was questionable whether or not they wanted to dig in before they realized how big the hole was.
Yeah, right.
So technically capable owners reps are also very valuable.
Does that mean you have some conversations with the owner when you go to bid the project about the professional services budget and how they want to prioritize value in there? I think about
Yes, I got
the save on hiring you and then later it can be the another person.
yes, and especially that conversation is really easy to have is if they've already had a project or two where it didn't go very well. It's so much easier to talk to somebody. It's like, okay, here's not only lessons learned from your specific project, so it becomes relatable when you have that conversation, because you can talk all you want about your experiences. If you can't become relatable in that story to that person, it's just like a contract interview, you're technically competent. I mean, this whole room's technically competent, that's why we're where we're at, but can you also communicate it and can you be relatable? And yes, I've had those conversations, and the horror stories I've found are more, it's so much easier to have a strong relationship out of a bad project and a long lasting relationship from one of those projects, as long as you were part of the solution or were a part of the accountability of that team to get past that finish line. And so everything from, I love great projects that are easy, and everybody feels great about it and we save this much money, but those bad experiences are much more valuable to me and have stuck with me for my 15 years, which is, might pale in comparison to a few people in here.
I don't know, on that video, you mentioned training, and that sort of vendor or trade-based training is maybe not the most effective way. Do you have any recommendations on better ways?
I do. So when it comes, I go over the training specs. So the question was about how do you improve the training process for these high performance buildings, basically. How do you change that? So spec wise, start taking a real look at the hours commitment. It's not just 23 days of training on the mechanical systems, which no one ever uses, but you end up having to have a very specific description for what are the responsibilities of the construction team on training and collaboration with both on the documentation side on what they're supposed to be providing, how it's recorded, but what the role of the CXA is, or the person that you're deeming is your best training resource. And I've a little biased as a commissioning authority, I find I have the most usable functional knowledge of the system, but having that designer there paired with me as well would be immensely helpful, because they can communicate the concept and I can convey a lot of the practical application and usability side, and you become a very good pair to assist the construction team with doing that training. So you almost want to do a panel format, and because you want to do a story, that's how people listen and retain stuff. If you're just going over the drawings and here in person, with the loud noise behind you from the compressor room and everything, and the classroom lost half of the people by minute 20, and in the field, the 3 closest persons heard everything and the rest of the people didn't. It really becomes important in the specs listing out, and I say specs just because you want that baseline there, but I end up working with the GC team to do this and get the hours put in my contract to do this, to make it professional. And so making sure that you have the contractors know how many hours they need to devote to it and what are their requirements, both from materials and their agenda, and not just say provide an agenda, provide a detailed agenda on a half an hour session, basis. And I can send you some specs that I've rewritten for this type of stuff, and I'd be happy to share them. Because for me, I'd rather see this just implemented everywhere, because once a construction team goes through and has the time in their budget to do it, they won't want to do it another way. On a high performing building, different. Everybody should have the budgets to do what they need to do on those for the most part.
Yeah, that'd be great.
But
All right, probably last question online, and thank you everyone for joining in. So a quick question around automated window controls. Looks like the windows on the second project need to be open to activate natural ventilation. However, the diagram specified the windows were open immediately.
Yeah.
So is there, what's your thoughts there?
So for the problem is that everybody wants to have it's sort of automated to avoid user controls, but you're just not going to get motors on every single window. It's different. It's just not practical. Then you have a whole other set of problems potentially with that. For me, having as simple controls as possible is going to help. Manually, windows have been the most effective that I've seen used. Damper sets, if you want to avoid the user controls, but then you present more problems with the dampers, as I've talked about. So it's a give or take. I think the windows are the most effective, both on the ceiling level continuously for the life of the building, as well as if the users want to use it, they will use the windows. So
I think the LED light as well.
the LED light is helpful, in indicator whether it's, I prefer to see it open, a contact closure telling the building automation system it's open and closed just from a security standpoint. Even though a lot of those optical windows, they've narrowed it down to they can only open it like that far now to prevent somebody from getting in. So I think the window approach has been the most effective that I've seen.
Or printers.
And well, because you can't put screens on it, and then they always want to put screens in after the fact, and they never fit very well. They don't last very well. Screens get destroyed at home, in the school, even more so all the time. And then filtration, you're never going to put filters on a screen. You're definitely not going to put it on a louver set unless that is your main outside air method into a space, say like a warehouse or a workshop or something like that. So windows are, and with limited controls, it's been the most effective.
So I've shared your email address with the group. So if there's any additional questions, they can send them to you. Other than that, thank you everyone for joining in. Really appreciate it.
Thank you.
Thank you.
Thank you.
Thank you.